All right, let's talk about numbers in chemistry, specifically measurements and significant figures. Now, we want to make sure our numbers correspond to reality. And the way we do that, at least when we're taking a measurement, is we always report one more digit than the scale provides. Scientists assume, whether it's a problem or in the measurement, when you report that last digit, that is an estimate. Okay, it still has significance, it has meaning, as we'll see, but it's an estimate. Okay, and lastly, make sure you have
Unit.
numbers. So let's look at a couple examples. Look at the graduated cylinder on the left. You'll notice that our reading is between 10 and 20, and these are milliliters here. We would have that marked on the cylinder. And between 10 and 20, you'll notice that there are 10 little lines. So that means that each line represents 1 milliliter. You might remember from a previous class, science class, that when we read the graduated cylinder, we always read from the bottom of the meniscus. So I'm drawing that in there as best as I can, but it sure looks like it's right on the line. So we would report this measurement as 17.0 milliliters, okay? Now, let's look at each number. So we know the tens place right here, the tens place, no problem, right? It's 10, but it's not 20. That's this number. The 7, we know for sure that corresponds with the reality because look at, we're all the way up to the 7th mark. Now, this last number reported, that is an estimate. We're saying that that's right on the line, okay? And that number, again, is significant. You could have said it's 17.1 milliliters, and that also would have been correct, saying it's a little bit above the line. Again, that last number is an estimate. Okay, let's look at the burette on the right. Now, in this case, the burette, now the numbers, little trick there, the numbers rest right on the line. So if you look, for example, between 21 and 22, there are 10 lines again. But because there's only one value in terms of being a milliliter and there's 10 lines in between it, that makes each line a tenth of a milliliter, right? So when I read the bottom of the meniscus this time, I can see it's 22.1, 22 nope, it's not quite to 22.2. So we would record this measurement as 22.1, and again, this is an estimate, 9 milliliters. You could have said 22.18, 22.19. You couldn't say 22.20 because it's clearly not quite there yet, all right? So again, this number right here is, my scale gives me the tenths place. I report to the hundredths place, and that 9 is assumed to be an estimate. So let's go back, look at the graduated cylinder just as a review, right? We have the ones place here. We report to the tenths place. Here, our scale gives us the tenths, right? These are tenths of a milliliter. That's this right here, and we report it as to the nearest hundredth, and that last digit's assumed to be an estimate. What we couldn't do is write the number 22.195, for example, milliliters, okay? Just throwing on numbers for fun. Because, remember, this is what we know for sure. This is an estimate. What's the 5? Well, the 5 doesn't correspond to any reality, so that is make-believe number. Okay, let's move on to rules for significant figures. Now, what makes a number significant? Well, assuming the measurement was done correctly, any non-zero digit, 1 to 9, is going to be significant. So 1, 2, 3, 4, all the way to 9 will be significant. The question becomes about the zeros. Are the zeros significant? Now, there are certain rules, as we're going to go over right here, to determine that. First up, a sandwich zero. What I mean by that is a zero that's between two significant figures. And by the way, a lot of times we're just going to abbreviate significant figures as sig figs, just fun to say, and it's quicker, so you'll hear me say that as well. So we got 2 sig figs right here, the 2 and the 1 for sure, but what about that 0? Well, because it's sandwiched there, okay, it is significant. So this number right here, 201, has 3 significant figures, okay, so 3 sig figs. Sorry for my writing here. I'll try to make that a little bit clearer, all right? So that's the sandwich 0. Next situation would be, what about those zeros in front of the significant figure, the non-zero digit. For example, like what if I have 0 point, let's just say 051, for example, okay? Notice here, my first non-zero digit is the 5, so that's significant, but I have these zeros to the left. What do we do with those? Well, because they're leading up to or to the left of our first significant figure, the 5, those are not significant, and they never will be, okay? So leading zeros, they're just placeholders. They're just there to take up space. They're important, but they're not considered significant. So this number, 0.051, is considered to have 2 sig figs, okay? Lastly, the last place the zero could be would be behind, or we call that a trailing zero. Trailing zeros are only significant if there's a decimal point in the number. So let's look at, for example, 6.10. That 0 is significant because it has a decimal point in the number. So notice the 6 and the 1 are significant. That 0 is because of that decimal point. So this has 3 significant figures, okay? What if I had the number 610? It looks very similar, but notice no decimal, so that 0 right here is not significant. So 610 has 2 significant figures, okay? And so I like this little diagram here at the bottom here. You can look over here as we kind of zero in here. You'll notice that this first number, right, these zeros again are leading. These are placeholders, so they're not significant. The 3, the 9, these zeros are significant because they're sandwiched, and this 0 is significant because it's trailing and there's a decimal point right there. So this number has 1, 2, 3, 4, 5, 6. This has 7 sig figs right here, okay? Notice our next number, if we look at this one, these zeros, again, are trailing, no decimal point, so they're considered ambiguous. Again, just placeholders. So this number has 1. Now this 0 is significant because it's sandwiched, 2, 3, 4. So this number, we have 4 sig figs here. And then lastly, all these numbers in this last number are significant, okay? So check it out. So this is a sandwich 0. These are trailing zeros, but notice the decimal point right there. That makes them all significant. So what is that? 1, 2, 3, 4, 5, 6, 7, 8 sig figs right there. So hopefully that helps you identify the significant figures. Now, let's deal with rules regarding rounding, okay? This should sound familiar, except for the sig fig part. First, you got to figure out how many sig figs you need to round to. More on that in a second. But remember how to round. If the digit to the right, okay, is 4 or less, you round down, which basically means that number stays the same, okay? So it stays the same if it's 4 or less. So you're going to locate the number of significant digits. You go to that digit and you look to the right of it. If it's a 4 or less, it's going to stay the same, okay? If the digit to the right of that significant figure that you're rounding to is 5 or more, you're going to add 1 to it. So 5 or more, you add 1 more. Okay, so let's look at a couple examples. So our first one, this number, letter A, let's look at this one, 23.46, blah, blah, blah. Okay, so it says to round to 3 significant figures. So sometimes you can either in your mind do this, or you can even draw a little line right here. Sometimes that's helpful when you're getting the hang of this. So I'm going to cut the number right at the 3rd sig fig. So 2, 3, and 4 are all significant, and I look to the right of that line. Notice it's a 6, that's 5 or more, so this would round to 23.5. And notice we drop all the other digits, okay? So now we have simplified that to 3 sig figs, or rounded it correctly. How about the next one, letter B? So in this case, remember those first 2 zeros, they're not significant because they're leading, so I'm looking at the 3, the 4, 4, and so I would cut the number off right there, and I look to the right of that 4, that's my 3rd significant figure. It's 4 or less, so that 4 is going to stay the same. So we round it down, which doesn't mean change the number 1 less, it just means it stays the same. So that would round to 0.0344. Okay? Lastly, okay, letter C. We want to round to our third sig fig, so we would look right there. So the 260, that's a sandwich, that's significant. And so I try to round this, and so maybe I try to round this to 26,000, and I realize, oh no, I only have 2 significant figures. So that presents a little bit of problem. So I can't round this to 3 sig figs using regular notation, but I can using what is referred to as scientific notation. So scientific notation is super helpful, okay? Sometimes it's the only way you're going to round it to the right number of sig figs. And it's also helpful, as I mentioned here, for expressing really large or small numbers, which I'll give you a couple examples here in a minute. But let's deal with our 26,000, for example. So we wanted to round this to 3 sig figs, okay? Currently it has 2 sig figs. So how could we do that? Well, we could put it in scientific notation. So let me review that with you. This would be 2.60 times 10 to the 4th power. So now our number is in scientific notation, and I've got the right number of significant figures. I've got 3. The 2, the 6, and the 0 are all significant. Remember that 0 is significant, it's trailing, and there's a decimal point. So we're all set. Okay, so what makes a number in scientific notation? Well, this number is the coefficient has to be between 1 and 10. So you're always going to have that. And then times a 10 as a base raised to some power. And what that means, if you remember your exponents, is it just means times 10 4 times. So you really could write this as 2.60 times 10 times 10 times 10 times 10, okay? And that, if you do it on your calculator, and I encourage you to do so, you'll get 26,000. Okay, so here we are on our calculator. Let me enter this as 2.60, and then I'm going to times it by 10. Notice the decimal place moved over once, times 10, it moved over again, times 10, moved over one more time, and then lastly, now we're at 26,000. So timesing it by 10 4 times really is equivalent to moving the decimal place 4 places to the right. Okay, so in a similar way, if I had 2.60, but in this case times 10 to the minus 4, that negative 4 means divided by 10 4 times. So that would be 2.60 divided by 10, divided by 10, divided by 10, divided by 10. Okay? And so in that case, again, we can try this on our calculator, but you can even now see, since we're dividing by 10, we're going to move the decimal place 4 places to the left. So let me do it here, and then we'll check it out on the calculator. So first, we would have our 2.60, and now you're going to move it 1, 2, 3, 4 places to the left, okay? And so we fill in the gap there with zeros, and so we get this number 0.00260. Okay, so I just wanted to show you here the 2.60. Now we're going to divide it by 10, divide it by 10, divide it by 10, divide it by 10, and notice what we get. It actually puts it in scientific notation for us. It doesn't know the sig figs because I don't have it programmed that way, but we have 2.6 times 10 to the minus 4. And again, we'd have to move the decimal 4 places to the left to get that into regular notation. Okay, so these numbers are equivalent, but they're different. Okay, so this number is in regular notation, this number is in scientific notation. They're the same exact number, they're just, you know, one's in regular notation, one's in scientific notation. And you might say, Mr. Lauder, why would I do that? Because I'd just rather write 26,000, even though it's the same thing as 2.060 times 10 to the 4th, I'd just rather 26,000 because that looks more familiar. Well, that's where our first point comes into play, okay? What if you have a really, really big number, okay? So, for example, we'll learn in our class, or you've already learned, that 1 mole is equal to 6.02 times 10 to the 23rd power. And that's particles, atoms, molecules, formula units. More on that in class. but it's a really big number. Okay, so you would have to times this number, 6.02 times 10, 23 times, or move the decimal 23 places to the right. Okay, so that's a huge number. And to save time, I'm just going to go for it right here. So I'm just going to go, now I know I've moved it twice, so I'm going to add 21 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 21. Okay, so that's a big number. Do you want to multiply, divide? Do you want to put that in your calculator, or do you want to just use that EXP key, 6.02 EXP, and then hit 23? That's what I would rather do. Okay. Likewise, a really small number, for example, would be like the mass of an electron. So the mass of an electron is 9.109 times 10 to the minus 31 kilograms. Okay, so that means we'd have to move the decimal, in this case, 31 places to the left. So that's a tiny, tiny, tiny number. All right, so hopefully that's helpful. I gave you the practice pages to get some practice. Do those now, and hopefully you're feeling really good about that. You can check online for the answers. Again, I hope you have a great day. I'll see you next time for the next video.